Great, we're live and we're back for the next lecture in the course on mathematical modeling of football. And Peter McKeever, who worked for Op now, is going to give the lecture today. And he's told me that he's not a mathematician. He comes from a very different background, but has become one of the sort of forefront of visualization, and it makes some very beautiful visualizations, which I'm sure many of you have seen in various contexts. He's going to tell us a little bit more about his background and how he got into this. So I think that will be interesting. But mainly, he's to tell us about how you use Python to make really beautiful visualizations. I always feel my visualizations are not quite up to Peter's standard. But I suppose no one's up to Peter's standard. But by the end of the course, you will all be up to his standard, hopefully, or getting towards it. But with no further ado, I will leave over to you, Peter. What I'm going to do while he's talking is put up links to his slides so that you can download them and look at them in parallel, and I'll update the web page so the slides are on. So I'm going to switch off my video, put on my mute, and leave it over to Peter. Thank you.
So, hi everyone. Very pleased to be a part of this course and this series. Today I'll be discussing kind of some basics to Matplotlib. The level for this course is, I would say, for someone who's closer to a beginner than a more intermediate level. So some topics that we'll cover are, some of the various elements of Matplotlib visualizations, and we'll walk through turning a very simple basic viz into something maybe a little bit more professional. So just as we get started, just to tell you all a bit about myself. So my name is Peter McKeever. I come from Dublin, Ireland. Currently I work with StatsPerform as a data analyst. I've been there for about 1.5 years now. Some of my interests, as I live now in Düsseldorf, of course, then Fortuna Düsseldorf. I'm also a big fan of Leinster Rugby, Dublin for Gaelic football, Green Bay Packers, and the Toronto Raptors in NBA. So just as we go through this, I'll just kind of go through a bit of my previous work. Maybe some you've seen, maybe some you've not seen before. So this first one here, this is one of my favorite types of plots to produce. I've not produced these in a while because we've moved to a new style guide with StatsPerform. So I've not had the time to get around to updating these to a new style. But there's, quite a few interesting elements in this visualization that I quite like. First of all, I think if I can grab, sorry there. First of all, I think let's go back. So that scatter plot across the top. So I'll grab my laser pointer. So up here, this is essentially just a scatter plot. With Matplotlib, there's not a defined function that you can use just to plot these. So it does take a small bit of mathematics to work out how you will arrange these points. But essentially, this is just a scatter plot using the x-axis as a way of equally distancing these points for each step. Also in this, something that I love to do quite often is encoding our labels within text. So for example, instead of having a legend here to describe, with a color for defenders, for midfielders, and forwards, we can embed this information within text. And by doing that, we can make the viz a little bit cleaner. We reduce the amount of char chunk, and it really helps the reader to, get a quicker grasp of what they're looking at. Another one of my standard vizes, which I've not put out for a while. I believe this is technically known as a Nolan plot, but I like to call it a diamond plot simply because it looks like a diamond. And this is one that I started putting out last year. In this, we can see possession value per 100 actions for different types of players. So this was looking at the German Bundesliga for last season. I believe this was almost, midway through last season. Yeah, specifically to talk to somebody about Serge Gnabry. But again, in this, it's something a bit more technical. I think it's probably beyond what we'll talk about today, but there are places, on Stack Overflow that you can find the basics of how to rotate your axes and so on. So it's a very interesting one to try out. I've seen a lot of people create these on Twitter. They all look really great. And so definitely, if you're up for a challenge, I'd say that's one to have a go at.
Can I ask you why you could ask why you rotate the axes in this way? What is that aesthetical, or does it have a scientific purpose to it as well?
I think it's a bit of both. I mean, if we're looking at a normal scatter plot and we're looking at relationships between an X and a Y variable, then of course it would make sense just to leave it as it is. But I think we're looking to categorize players more so than see what the relationship between certain values are. And for that purpose, I thought a rotated plot would be a bit more appealing. Again, it catches people off guard a bit. I think, one of the goals of good data visualization is to really catch the eye. And by having something a bit different, first you draw people in. And yeah, I think it's an interesting way of looking at it as well, especially when we're not dealing with any, we have no numbers along our axes here. So it's just maybe a bit more categorical than, trying to see what the relationship is. And that's the main reason why I did it. Also, I think it looks very cool.
Yeah.
And yeah, that's kind of the crux of it.
So I suppose but there is actually a reason when you think about it, the up and down and the left and the right carry a different piece of information.
Yeah,
so
sure.
You can squeeze in a sort of extra bit of information in some way doing that.
Yeah, and I mean, if I were to do this again, essentially this is a rating from 0 to 1 and 0 to 1. So here, this line here, it's, players who score over 0.5 in both of these metrics. Whether that's elite or not, I'd leave that up for a lot of debate. I mean, it's better than average. I'd probably bump it up to somewhere around here. But yeah, again, just as a viz concept, I've not seen it used in football before. So it was a challenge for me. And that's what I really like about visualization, is that opportunity to challenge yourself and to try new things, see what works and what doesn't. I have a lot of iterations of this that never saw the light of day because they, just looked absolutely terrible. But that's, part of the process really when finding these. And to move on, I mean, so it's not all, analysis stuff. I like to do a lot of design stuff. So for example, this next graphic here, I mean, this is not something that you would show to a coach or to anyone working within the professional world. But, as a design concept, I think it works really well. So here, this is just a standard polar plot. But there's some, smaller technical aspects to this that are a bit subtle that you wouldn't really catch unless it's pointed out to you. So for example, the season labels here, they have a slight curve to them. If you just plotted these as regular text, they would be a bit more jagged, but by having this slight curve, it helps the flow around this polar plot really well. Also within this as well, I mean, similar to the pitch plot that I had with those lined up scatter plots, it's a similar concept here. And this is looking at, different shot types, from open play, from free kicks, and from penalties, and the outcome of those. Again, instead of trying to encode what the colors mean within a legend or within a key, I've done that within text. Here, this is just to give some more information as well. But again, I mean, this is something purely more design focused than anything really, analysis based. It's not something that you would kind of push towards someone within the football industry, but for a nice visualization, I think it works quite well. Yeah, so another one that seemed quite popular when I first put these out. This is a graphic looking at central midfielders, how well they contribute to attacking output through expected goals per 90 and expected assists per 90. And I included this one here because this is something that you should be aware of when you're creating your own viz. The monitor that I use for my work is quite a high resolution. So when I see this graphic on my monitor, the text up here in the top right is very legible, but having looked at it on lower quality and on mobile, it's very difficult to read. So for that reason alone, this graphic is actually a failure because it doesn't do what its aim is to do, and that is to, convey a message and to explain easily what this is about. So when a reader can't, read what text you're including in this, you've not done your job. So it's something to bear in mind. You should always check, on different devices or on different platforms, if you're, putting out visualizations, that they are still legible. But yeah, so again, similar thing here. This is a bee swarm, one of my favorite bits to do. Here we just have a normal scatter plot, and at the bottom here we have a bar chart. Again, so today we won't get into how we create all of these different visualization elements. We'll just focus on, a regular scatter plot, but we'll look at how we can take it from the standard Matplotlib to something a bit more customized and maybe a little bit more professional. I think of, so on this one as well, again, this is something maybe just a bit more design than practical, and something that I really like. I think it works really well, including the team badges here along the bottom, the outcome of the games along the top, and this legend here to explain a bit more what each of these colors mean. Where this visualization falls down is around the 90th minute. So football, I'm sure there's never been a game of football that's ended exactly at the 90th minute. So we have some situations, for example, here, this game against Arsenal. So if you were just to look at this on its own, it would seem as though Southampton had won this match. But, sometime right at the very end of the game, Arsenal got a goal back and it actually ended in a draw. So if you were just to look at this without these labels on the top here, you would not be getting the correct information from this graphic. And I think that's probably where it falls down a bit. And this is something that I, put out personally. It's not something that was endorsed by OptaPro. I use their data a lot, so I, of course, include it. But yeah, again, so sometimes things can, maybe look cool, but practically they're not so useful. So it's something to keep in mind when you're creating graphics as well. The last one that I'll show you before we move on is the waffle plots. So I'm a big fan of these. I discovered a package called PyWaffle. So you can find it on GitHub if you look it up. The issue that I had with PyWaffle is an issue that I have with a lot of these, custom visualization packages that are built from Matplotlib. They are created with the intent of only working with a figure. So that means you can only plot one of the axes. I mean, you cannot reuse this. So instead of that, I had to create my own package for this. It's not released anywhere yet, but essentially instead of, needing a figure to plot one of these, I've moved it down to the axes level. So you can iterate over these and create these in subplots. If that's all a bit over your head, hopefully what we'll go through today will clear some of that up. So
can I just before you continue, with some of these things, and I know you've written about this before, so this is why I'm asking you, but there's a combination of you finding things online that people have used before and then sort of developing that and so on. Can you just say a little bit about that process and how, what the different focus is, how much of your work is like finding the right way of doing things and how much is it developing yourself and so on?
Yeah, I mean, I think it's part of the regular process. You see something that looks interesting or quite cool, usually from a different media. So, looking through a newspaper or through The Economist or, an interactive tool online, you find something that, is a little bit different from what you're usually seeing. My first step then is to see how it's done. Usually if it's online and it's in a publication, it's usually with D3. The line of work that we are in, data is rarely publicly available. So I'm limited to putting out things in D3 because it exposes a lot of data. So my next step is then, of course, to see what does exist already in Python. If something doesn't exist, I attempt to create it myself. If it does exist, I'll see if it, suits what I need it to do. And if not, then I'll kind of work with that to build out my own part of it. So I actually hope that once I have the code for this a bit more up to scratch, that I'll contact the owner of PyWaffle and I'll submit this as a pull request, because I think it's a good addition. And I mean, it's a graphic that I think people in the community are attempting to do, some more successfully than others. But I think it's one that, it's an interesting way of looking at it. How useful it is, again, at the end of a season maybe, but it's not something that you could roll out after week 6 of the Premier League, because you just wouldn't have enough information from that alone.
I'm just going to ask you one more question, because it's just come in. How long on average does it take you to make one of those? If you think of the 5 plots you've shown us, how long on average did it take to make each of those?
Well, I mean, the goal of my job especially is, partly automation. So now, if I needed to, if we had a request from our editorial team, if we could get this for, I don't know, top 5 leagues for the past 4 years, I can, produce it almost instantaneously. The longest part is waiting for the data to load.
Yeah.
And from initial concept, it's a bit of a longer process. And something that I'm not such a big fan of now that, access to data is so publicly available, is people who are interested in working in this space. They create something, just the first time and then put it straight out into a blog or into social media, when you should treat it more like, a piece of writing that you're doing. So you have a first draft, you move away from it for a couple of days, you come back to it, you see if you still feel the same way about it, you correct what, maybe is not working so well, and, you try to refine the code a bit to make it a bit more efficient. And yeah, so it's not just something that, okay, I've done this in 20 minutes and now I'm putting it onto social media. It's, it's a bit more of a process. If you think of it like journalism, a journalist isn't just going to submit their outline to an editor for publication. It takes a bit more training and a bit more honing of skills before you can get to a level where, the first draft is maybe a bit more close to the finished piece, but it should definitely never be, the end result. If that's a roundabout way of answering the question.
Oh, that's nice. Yeah, cool.
Yeah. But yeah, so, we'll talk a bit about some common pitfalls in database. So it's ones that, again, it's just things that I'm seeing now with lots of new people moving into the space. And again, it's things that, I've done myself when I first started out with creating visualizations. And it's just things to be aware of. So the first one, and this is probably my biggest gripe at the moment, is this scatter plot using, team badges instead of points. And the reason why this is an issue, there's a few reasons why. First of all, team badges are different shapes and different sizes. So you will never know what the exact figure or what the exact values that you're looking at on the X and Y are. Secondly, beyond some of these outliers here, it's meaningless. I think with these kind of visualizations, it's giving across a message that I know how to do this, or look at all this data that I have, but it's not doing the job of visualization. When we're creating data visualizations, it should be to either explain, to tell a story, to find something unique and interesting. But something like this, all it's doing is taking a table of data and making it more complicated to understand. And it's something that I'm not a big fan of. In saying that, I think there are times when using team badges can be beneficial. So for example, if we were only looking at, Liverpool in this visualization, maybe you could probably get away with just using Liverpool, because again, you're going more towards a narrative then, and not just saying, here's all of the data that I have. So it's one that, I think if you're using it, maybe use it with a bit more caution. definitely to limit the number of teams or the number of badges that you're using. Another one is too many colors. So again, this is just for demonstration purposes. I wasn't going to sit down and get 36, unique colors to make this point even more. Too many colors in graphics just muddies the details. It makes it too complicated. Really, when you're creating viz, maximum 3 or 4 colors would be, kind of where you should be looking at. Anything more than that, you need to start explaining it a bit more. And again, this is something when I started out, I was, I did quite a lot. And yeah, it's just something to keep in mind, that you may feel like you're explaining it a bit more because you have this legend, but you're really not explaining anything because, you're not really getting anything out of that. To move on. So another one, this is something that I see quite a lot as well. So people who are, or data viz creators who are, embedding team names in the title, which is excellent. I love to see it, but they'll embed the name of the team in a color that is not used in the graphic itself. And again, that's defeating the purpose of that, that purpose, the encoding that you're trying to get across by having a different colored, word, is to make it easier for the reader or the consumer of the media to understand what it is they're looking at. And again, it's one to keep in mind, seeing it like that, it can come across as, I know how to do this, but it's not actually offering anything practical to the visualization itself. Another one, this is again something that I've done a lot, and it's minor compared to some other bits, but it's still something to be aware of. And that's using the same shade of color that's maybe a bit too strong with the main color that you're looking for. So when you look at this, you can find the main piece of information that you're interested in, but you also have these shades that are, maybe a bit too strong, that it takes a bit longer to find it. Whereas you should probably look for maybe a more neutral color, a color that fits more with the background, just again, to give that idea that these are not important. The only thing that we want to focus on is, this main point here. I've just a couple more of these and we'll actually get into the good stuff. So this next one, again, something that I've been seeing a lot lately. Yeah, I don't really have much to say about this other than it's not a good idea. And generally backgrounds shouldn't be the main focus of a visualization. They should just be the background. When you have these vibrant colors, you're distracting from absolutely everything. So, I mean, it is eye-catching, but I think for, the wrong reasons. And again, so just something to keep in mind. So I have just 2 more that we'll quickly go through. So this one here, dark themes are absolutely all the rage. I'm a big fan of using dark themes myself. I would point out on this though, using pure black is not really a good idea, especially if it's pure black with white text. It's very straining on the eyes, especially if you have a lot of information to put across. I'd say it's always better, instead of using a completely black theme, to go with something a bit lighter. So for example, here, this shade of gray, or even lighter than that. Yeah, instead of just the pure black. And finally, just the typical traffic light plot that you get, the red is bad, orange or yellow is okay, green is good. And again, so just to be aware, when we are creating visualizations, that not everyone will see color in the same way that we do. And for example, with this, for a colorblind person to look at this, it gets a bit more difficult. It's always a good idea to make sure that your visualizations are reader friendly from, people across the spectrum of vision and so on. And so on this as well, there is a program that you can download called Oracle, and you can click on this. It will change your screen so you can see it the way, people of varying types of color blindness kind of see things, and that will really help when you're deciding on what colors to pick for your graphics. So,
Matt, can I just come in on that one?
Yes.
Sorry, can I just come in on that one? I know you're keen to get on with the thing, but one thing I wanted to say about this is that if that was in a scientific journal, there would be lots of problems because you said good, medium, and bad, and so you can
As
do
an
it.
example,
You can do it on a figure for if you're trying to illustrate a point, but there is a sort of misleading thing because there's no real way that you classified those. Have you got any general rules for balancing a decision about when you use that type of thing? You also did it with the players when you had the cross and you put them in the four categories and chose different
yeah.
colors for them there. Have you got any rules for do's and don'ts about that?
And for the choice of colors, or
No, for if you have a choice, if you use colors or not. So if it was a purely scientific plot, you probably should not use colors because there's no real reason to classify them as different.
Yeah. Sure. I mean, just for us, we're in the business of analysis, and with football especially, I know it's quite different from a scientific journal. Again, I used here good, or good and bad, purely as the connotations that people have with the colors red and green. Where possible, definitely try to avoid using red and green together. There are various other ways of doing this. I believe there's an analyst, her name is Lisa Rust. She works for Data Wrapper, and she has some very good tutorials on how we can encode our graphics in certain ways to avoid the use of color and so on. And that's definitely something I'd recommend checking out. Hopefully I can post a link at the end.
I'll put a link. I know about her work. Yeah.
Great. Okay. So, okay. Let's go through. Okay, so we'll just first of all run through a default Matplotlib. So I'm just using some randomly generated data for this, and just to kind of get the idea across of how a beginner might just generate a graphic in Matplotlib. So we start off by creating a figure and an axis. These are often shortened to fig and ax. And we create, so we create these with a fig size of 8 and 8. So the first number here is our value across. Our second number here is our value vertically. So from that, we can add just a small grid. So with this grid, we set the line width to 0.25. So this just creates a thin line, probably barely noticeable on your screens. And we set a Z order to 1. So Z order is for layering. When we talk about Z order, the lower the number, the lower in the layers it would be. It's something that we'll come back to later, and just to point it out for you now. We can use the .set title to add a title to a graphic. So this is the title using default Matplotlib. And just be aware that if you don't pass any extra keyword arguments here, it defaults to plot in the center of the figure. So next we'll just add some randomly generated data. So I've added a seed here. So if you use this seed 402, you should be able to recreate this. So here we have an X. So we've created some X and Y values, and we use a scatter to scatter our points. Again, here I've used Z order equals 2. This just tells Matplotlib to plot this on top of the grid. So just to bump this up a bit, we can use the S keyword argument to change the size. So just bump these up to 400, maybe a little bit big. And again, I mean, looking at this, it looks okay. So we can kind of tell, where most of the points are. So here, we can get a rough estimate of where the center point of each of these would be. However, down here, so I hope you can see my pointer. So down here, it's a bit more difficult to see where one of these points, begins and the other one ends. So to deal with this, we can add an edge color. So an edge color just adds a border to each of our points. So here I've added an edge color white, and I set the line width to 0.5. Again, it's just a thin line, but it does just help distinguish where kind of these points are and which points are overlapping and which aren't. So we can also limit our X and Y axes by using set X lim and set Y lim. So here I've just set these to 0 and 1. So here we go from 0 to 1, and again, vertically from 0 to 1. And lastly, I just applied a tight layout. So this helps with your margins, especially if you have a title that goes above your original fig size. So when we use tight layout, it just helps sort those margins out. And lastly, we use .savefig to save the figure. So my project structure for this, this was mainly run from a notebook within a notebooks folder. So in order to save this in a plots folder, we go up one directory from our notebooks folder into the plots folder, and then this is the name of the file that was saved. And so on this, I set bboxinches equals tight. Again, this is just to help make the margins a bit cleaner, make sure there's not so much white space around your graphic. And we set the DPI to 300. This just makes sure that our graphic is of a high enough quality so the resolution doesn't drop. I think if you don't include that Matplotlib, I think the default is 70, which is quite low. So again, one to keep in mind when you're saving your visualizations to have a DPI on it. So just before we go ahead, just see if there's anything in the chat. Do you plan to come back with tutorials on your website? When I have time, I think I will migrate my website. It was on WordPress, but it's quite slow. I'm going to host it myself, but again, time dependent. I hope, before the end of the year, I'll have some tutorials up again. Okay. So elements of Matplotlib. So what's what? So in this next section, I'm just going to talk briefly about some of the main elements that we use when we're creating graphics in Matplotlib. So I didn't create this. I couldn't find the author for it, but you can find a link to the web page for it here. So when we look at a Matplotlib plot, there's a couple of elements that we need to know about. So first of all, we'll start up here. So this area outside of our plot area, this is known as the figure. The area inside is known as the axes, or the axes object. And so again, this is something that we'll come back to because it's important to know what each of them are and how we can work with each of them. Up here, we have a title, of course. Along the sides and along the bottom, these little lines that you have, these are called ticks. I call them pips, but these are your ticks and these are your tick labels down here. So down here, we also have the axis labels. So the x-axis label and the y-axis label. And within inside the plot, then you have the spines. So the spines can be thought about as the border for the graphic that you're looking at. So for example, here, this will be the top spine, the right spine, the bottom spine, and the left spine. And yeah, so we'll talk about each of these in turn. So first, when we look at the, we'll look at the figures and the axes because they're not the same thing. So as we did in our first example, we can create a figure and an axis in one function by using plt.subplots. Once this is created, it's important that you set a face color for your figure. The reason why this is if you don't have that set and you save this graphic, this outline here will be transparent. So usually, of course, this will be the same. You would want this to be the same color as your axes object. Other times you might not want it to be, but definitely be sure to include a set face color on this. Otherwise, if you're viewing this on a dark background with black text, you won't be able to see your tick labels and you won't be able to see your title. So just want to keep in mind here. So we can plot text on the figure by using fig.text. So yeah, this is the figure. Font size controls the size of the font that we'll use. And again, we can plot text on the axes object by using ax.text. This is the text on the axes object. The reason why we use ax here is because we've defined it up here. We could call this, we could call this, I don't know, area, and then this will be area.text. I wouldn't recommend you do that though. Ax is like a defined nomenclature in Matplotlib, which usually refers to the axes objects. So it's good to stick with that, especially for other people who are going to be reading your code later. So we also have lines in Matplotlib. So we plot lines by using ax.plot. So when we create lines, we can add a few keyword arguments to it. So we can add a line style, often shortened to ls, and a line width, often shortened to lw. So the styles in the graphic over here are as follows. So if you wrote ls equals hyphen, you would just get a normal solid line. If you had 2 hyphens, you would get this dashed line. Dotted gives you more of a dotted line, and so on and so on. Again, I've included more information here at the bottom if you're interested in seeing the different types of lines that you can create. So when we create lines, we have 2 main ways of doing it. So if we have a list of x and y coordinates, we can plot them together with x.plot and just use x and y. So this will draw a connected line, as you see here. You know, basically it will use the, so the endpoint will be, you know, the second value in that list, and so on and so on. So they all plot in one continuous line. However, if we wanted to plot lines individually, for example, in football, if you're looking to plot passes, or if you're looking to plot crosses or player shots and so on, you know, this is more valuable. So we can do this by explicitly defining an like a endpoint for the x and y values. So by you can put these together. So for this is a for loop using a zip function. So zip basically just kind of gathers all these together and it takes them out one by one. So we can say for the first point, which here is 0, for x, and the first point for ex, which is 0.9. And again, the same for y, 0.2 and 0.1, which would be this line here. It just plots that from the start to the end. Again, just something to keep in mind as well. Okay, so markers. The default that you get with Matplotlib is the circle marker. So if you used x.scatter without defining what the marker value is, you'll just get this initial value here. But I mean, there's really a lot that you can include in this. I've only picked a handful. Again, the link at the bottom here, you can see all of the ones that are available. But these are, you know, some common ones. So ones that I really like to use is this X one here. I think especially for negative actions, I think it's quite nice to use. But yeah, I mean, there's really a lot of options that you can choose from. And the way that you choose these is by using the marker equals and then whatever string of these that you would like to use. So along with the shape, we can also, you know, set the size of our markers again by using this S argument. So S equals, I believe the default is 120. I'm not sure, and it could be a little bit more. But yeah, you can control the size of your markers by using the S flag. We can also set the transparency with alpha. So alpha is a value between 0 and 1. It's important that you don't go above 1 or below 0, because if you're saving an SVG file, for example, you'll get an error, and it's very difficult to track down what that error is if you don't know that those are the bounds on alphas. Yeah, so we can also add edge colors to our markers. So yeah, edge colors, again, as we've seen in the first example, it just helps define what the edges of our markers actually are. And yeah, so, and we can also adjust the line style and the line widths of these edges as well. So I've just given you a few examples of ways that we can work with markers. So we can set, for example, edge colors to black, which will add just a black outline to it here. We can set the color to none as a string. It's important. And this will, yeah, just create an empty marker. I have the edge color equals black is still on this, so you still see the outline. It's important to note here that this will be transparent. So if you have anything underneath, you would be able to see that. So for example, in football, if a player makes a pass from the edge of the 18-yard box, then you would see the line below that. Alpha, again, as we just talked about, this controls the transparency. The lower the alpha value is, the more transparent it is. And lastly, hatch. So there's a few different hatches that you can use. Again, I've included a link down the end here that you can see what those other hatches are. And this just adds, you know, some lines and so on across your markers. Okay, and ticks and spines. So when we are creating our visualizations, for me personally, it depends on the type of graphic that I'm creating, but if I'm using a scatter plot, I tend to not include the top and the right spine. A personal choice, I just think it looks better, but You know, many people like to just plot with none, or, you know, maybe just have a different color. So it's always good to know how we can work with these. So again, if we just created a normal plot, so just using fig, ax, and our PLT subplots, this would be what we would get. By using ax.spines, you know, whichever spine we want to look at, and set visible equals false, we can remove those. You know, we could also set the color, as we've done here on the sides. We can, yeah, do a lot of things with our spines as well. We can also use tick params. So tick params are used to interact with the lines that we have here and also the values. So you'll see here on the x-axis, I've changed the color of the lines to blue. I've made them a bit longer. I've made them a bit wider. And on the y-axis here, I've rotated the values a bit, and I've completely gotten rid of the lines. So again, for me personally, I'm not a fan of having these lines, especially if you don't have if you have no spines and you have, you know, just the default Matplotlib, which would be this black color here. If you plot a grid, usually the grid will be a lighter color, which, you know, it just doesn't look right. So it's something that I prefer to take off, because the grid lines indicate where these values are anyway. Next, we'll move on to text. So there's lots that you can do with text. I'm not going to, you know, be able to cover everything, but just to give you some of the highlights for it. When we use text, we have a few options available to us. So one of the most important ones to keep in mind is your alignment. So HA, which is short for horizontal alignment, or VA, which is short for vertical alignment. Yeah, this will really help when you're trying to add some extra bits to make your visualization a bit clearer, to explain something a bit more. So it's always good to know how we can use those. So horizontal alignment accepts a center, left, or right argument. So up here, we see this is centered, center aligned horizontally. This is to the left, and this is to the right. If we rotate our text 90 degrees by using rotation equals 90, and the alignment is then done vertically. So if you wanted to have your vertical text aligned in the center, again, we'd use center, or you'd use top or bottom. Yeah, as well as this, we have path effects. So path effects is something that we'll talk about towards the end. Path effects are very cool because it really helps when you're dealing with adding annotations or adding labels to graphics that are maybe a bit more complicated. As well as this, we can drop to a new line by using \n. So this exactly here, I couldn't add this into the text because it would have dropped down a line and not shown what that was. So that's very useful. Matplotlib sadly has a few issues when it comes to working with text. The reason for this is to adjust text. First, Matplotlib needs to render it, find the locations, and then you know, make the necessary adjustments. So the issue with text on this is that text is really something that you can't automate so much, especially if you're dealing with, for example, in the Premier League, as we'll see later, if you're working with a team with a short name, you know, titles can be fine. If you have a team with a longer name, for example, in Stats Perform, the team is not known as Wolves, it's Wolverhampton Wanderers, which is quite a long name. West Bromwich Albion will be another one next season. That's going to be a bit of a pain, but you might need to make some, you know, some if statements so you can make your text a little bit smaller if the string length is above, you know, a certain amount. So yeah, with our text, we can also set the weight and the style. So our text weight is, you know, how bold we want it. So you can use values for this. So 400 would be a normal standard font size. 800 would be bold, 200 would be light, or we can just use, you know, light, medium, bold. You know, there's a few that we can use for that, but this will adjust the weight of the text. Style then, this looks at, you know, is the text normal? Is it italicized or is it oblique? And again, it's something that you can pass to it. At the end, we'll see the finished graphic that we have, and I use this a lot for credits at the end of visualizations. So at the bottom, just my own name, and the data source I tend to use in italicized style. Okay, we've spoken about it already, but just to go over again, alpha values.
Sorry, sorry, Peter. Just one question that came up
Yes.
about the text. It was a question about if you want to add an arrow from the dot to the text, like you've written some text at the side. How do you do that?
So you can do that with ax.annotate. So this is not really something we'll cover in this tutorial today or in this lecture today, because it gets a bit more involved, and just looking at the time we've already gone through, I don't think it would have been wise to spend it on that.
Okay.
But yeah, that ax.annotate for a lot of stuff like working with B boxes or working with, you know, more specialized arrows and so on.
Cool.
And just to point out, so in, for example, these, because these are one-off visualizations, I didn't waste the time, you know, adding these in Matplotlib. It's much quicker just to open up your local, your whatever you're using for your, you know, Paint, or I'm on a Mac, so in Preview, you know, you can just add these kind of on the fly. Again, purely because it's not something that I plan on recreating. It's only for the purposes of this. So it's just much easier to do it in that. Of course, if you wanted to use some of these more advanced arrow types and so on, ax.annotate would be how you do that with arrow props. And yeah, so just to reiterate with the alpha values, 0 is your minimum, 1 is your maximum, 0 is invisible, 1 is fully solid. Okay, so under the hood, so Matplotlib takes a lot of its defaults from RC params. So there's currently over 300 of them. We definitely don't need to know them all. You know, there are style sheets that do exist that you can use if you just want to update a theme very quickly. You know, so for example, there's a 538 one, there's a Seaborn style that you can grab if you wanted. But personally, I'm not a big fan of them. I like to create my own. But yeah, so if we wanted to work with our RC params to update them, so for example, if we wanted to change our default font for the session that we're in you know, in our notebook or whatever, we could say npl.rc params font.family equals Century Gothic, for example. And if we change a lot of these and we want to go back to our defaults, there's a there's a command down here that we can use. Generally, I just dump this into a function called reset matplotlib, and this will reset all of your values back to the default. So it's a good one to know. But again, it's something that we'll come back to later on. Okay, so the main ones that we'll look at, or the main ones that we tend to use, are for face color. Again, this just makes it easier, so you don't need to set this every time that you're creating a new viz. And for font, if you always want to use the same font. For our Xtick colors, our Xtick, you know, fonts, our label sizes, generally things that we will use in multiple vizes, but we don't want to type them out again and again, would be a good case to, you know, maybe work with your RC params instead of having to do that. Okay, fonts, this is included in the PDF. This will only work in Jupyter Notebook or in a IPython notebook. But you can use this if you basically copy this from the PDF, I hope. You should just be able to paste it into a cell and run it, and it will print out the fonts that you already have installed. So this is quite good. If you want to use a font other than the default that you get with Matplotlib, you can see what you have available. I believe this is an issue with the HTML, but some of the fonts don't render as they would actually look in Matplotlib. But you'll see them because they look, you know, basically just like Times New Roman. But again, just want to keep in mind. But that will be a you know, a quick win in figuring out which fonts that you want to that you have the option of working with. Changing fonts, again, we won't go through all of this. I'll just point out a very easy way of changing your fonts is to just declare them as variables. So for example, title font and main font. Allegre Sans is a font that I use a lot in my personal visualizations. It's not something that you'd already have installed on your machines, I guess. If you wanted to use it, you could get it from Google. That's where I got it from for free. And yeah, main font, then Open Sans. Again, I don't think this is just openly available. But yeah, so from that, again, you can just in your text object, you can say font family equals main font, or font family equals title font, whatever you like. So looking at the graphic here, for the title, for the X and Y labels, I've used the title font. And here within the plot itself, I've used the main font. Okay, again, just to go over Z order again, it's really important that you use this because it can take, what would be a quite good visualization and just make it look poor, make it look lazy, because you've not taken the time to see how things should be layered in your visualizations. I mean, the way visualizations work is by building from a base in layers. It's not all about putting everything down at once. It's about starting from the bottom and kind of layering up on it. So when you don't set your Z orders, for example, what can happen is your grid will plot on top of your points. If you added your text before you added your scatter plot, then this point here would be above your label. So again, knowing what you want to plot on top of each other is very important, and using Z order on that is also ideal. So again, just adding Z order 1, Z order 2, Z order 3. You can see the grid is now on the bottom, points on top of that, and again, the label point is on top. So just to visualize that a bit clearer, if you think of it as these layers, this first one here would be our grid layer, Z order equals 1. This would be our second layer, Z order equals 2, just for the points, and then Z order equals 3 for our point label. Again, there's no, I don't believe there's a maximum in the Z order that you can set. I believe you need to start with 1, but whatever the higher number is, that will be plotted on top. So one to keep in mind when you're creating your graphics. Okay, so finally, a real world example. Just before I go into this real world example, David, if you've noticed any questions in the chat, please let me know.
Yeah, I've got one that just came up right away, just now actually, which I think is interesting. Interactive visualizations. What do you think about them, and why don't you do more of them?
So I've briefly mentioned this earlier. I'm in love with interactive visualizations. I do a lot of personal stuff in D3. It's one of my favorite bits of data viz to do. The issue with doing it professionally or in the football analytics space is that we work with non-public data. When you create D3, every piece of data that's in that visualization is available through the console. Yeah. And again, it's a data exposure issue. Of course, working with Stats Perform, I wouldn't feel great about working with other companies' publicly available data to create these graphics. But yeah, I mean, it is something that I really love. It's something that Tim Bayer has done some great work with recently, looking at Fantasy Premier League using D3. But, it is something I like to do personally, but sadly not anything that is out there in the public. But yeah, cool. My favorite background, so Christopher Aryo, my favorite background color for Viz is currently this one here that I'm using. Again, it's not something that we use in Stats Perform. We use a slightly different shade of gray, but this is the one that I'm a big fan of lately. I think you have a lot of options of what you can plot on top of it. Okay, so diving into our real world example. Again, this is all in the PDF, so don't worry about trying to follow all of this text. I know it's quite text heavy. A lot of this is standard. Some packages that you will need to pip install if you don't have them already are Pillow. So from Pill, you get this image. This is used for adding team badges or company logos or whatever to your graphics, and highlight text. So I've corrected a little bit of code on this. It's still in development, so it can be a little bit buggy, but this is what we'll use to plot our text with multiple colors. So it's quite a good package to have. So on this, just to talk a bit about the data set. So the data for this, it's just some summary data that I put together from footballdata.co.uk. It looks at goals for and goals against for yeah, all the teams in the Premier League from 2010 until the previous season. You know, if you want to work with this data, or if you want to follow along with the tutorial, yeah, you can get it on my GitHub. So that link here will bring you to that. Okay, and again, the issue with doing these in PowerPoint and not live is that you don't have the option of displaying full code. So again, I've added this in the PDF as images, but there's also a notebook available at that repo that has the completed code for these graphics that we'll look at. So just to start out here, so this is a basic visualization. You know, it's not good. This is what you would get if you just put everything you had into Matplotlib without making any adjustments. So we have the default font, which is Deja Vu, and same for the X and Y labels, the default colors for Matplotlib. We have no Z order, so the grid is plotted on top. The main color, so the main bit that we're interested in is Arsenal 2019-2020. So I've got that from here. So just by doing a simple filter on a pandas data frame, just to get the team that we're interested in, which is Arsenal, and then plotting the X and Y values for them, as well as the last season, so which would be 2019-2020. And again, I'll go back to this in a bit more detail. But again, this is just to show a very bad, very basic viz. If you just plotted with Matplotlib and said, okay, that's it, my job is done. This is really only the starting point. You know, there's, this is what you build from. It's not the end product. So the first thing when looking at this is, you know, what is the data that we're looking at? So we've goals for and we've goals against. The nature of this graphic means that these goals against will, you know, it's better if they're down here in the bottom right-hand corner, but that's kind of counterintuitive to how we interpret these types of scatter plots. So you might have noticed earlier in other examples that we've reversed this. So for the purposes of this, I've decided to reverse it again. You may agree with that, you may disagree with that. But again, for the purposes of this, I've decided to reverse the y-axis here. And again, it's a small thing, but it helps the consumer of the graphic know, you know, kind of a bit clearer that, okay, up here is what's good. Or again, I shouldn't use that word, but up towards the top right-hand corner, you know, it's generally where consumers, especially non-scientific consumers, will look to see, you know, what the better end of the scale is. Okay. Yeah, so moving on, the first thing we'll do is just change the background. Again, this looks really bad. It's just the first step. And instead of having to say, okay, whatever my background color is here, I'll add that here, I'll add that here, and so on and so on. We can just use it as a variable up top. So by having it as a variable up here, if we reuse this, you know, in many different places throughout the visualization, we only need to change it in one place. We don't have to change it each time we use that background color. So I've just named this background, you know, just a very clear label, a very clear variable name. And again, background for our fig.setFace color and for our axe as well. So interestingly, with axes objects, when you create them, they default to white. So if you wanted to work with, a different background color, for example, we can do that by using axe.patch and then set face color to whatever the background color you want to use is. If you didn't want to, like if you wanted to hide all of the ticks and all of the labels and so on, you could say axe.axes off, and that will just delete everything. So your points will still be there, but all of the axes elements won't be included. It's a bit of an aside, but just want to be aware of. Okay, so next we'll have a look at the text color. So again, instead of changing every time I use text, instead of using color equals white in, how many, 1, 2, 3, 4, 5, in 5 different places, just simply by having that as a variable at the top of your cell or of your script, it just makes it much easier to manage. You only have to change it in one place. You don't have to do it again and again. Okay, and so this is the first dive into the RC params. Again, this is something I'm only going to use white text in these. So I just set the the tick color to the same as my text color. Again, just a pure design choice. So just want to be aware of. Okay, so from the tick color, we can move on to the scatter and the line colors. So what we had before this was, again, this blue, not very appealing, and this orange, these default that we get with Matplotlib. And the only point that I'm interested in really kind of highlighting is Arsenal for this season, or sorry, for the previous season. So for that, instead of, as we saw earlier, that I had it with, a lighter shade of red, using a more subdued color that fits more with the background, just kind of helps the reader along in showing that, okay, maybe these points aren't as important. The point to focus on is here. So what I'm showing here actually, so from the start of this line, this will be season 2010, 2011. And this is the goals for and goals against for Arsenal over the past however many years. So again, going up this way, teams have performed better in terms of goals scored and goals conceded. Arsenal last season, I'll say no more. And again, so here, instead of having to say, okay, I want this 1 point to be red in the ax.scatter, or I want all the other points to be, a gray color, we can just set it as variables up top and then use them. But we only need to change them there if we want to change them. Okay, and moving on. So for the grid and the Z order, so I've cleaned up the grid a bit. So in this, I changed it from its default just to a dotted line. I've made the line width a little bit thinner, and I've changed the color to a light gray, and I've set the Z order to 1. So this should be on the very bottom. And yeah, each of these points, they're layered again. There's Z order 2, Z order 3, and so on and so on. And again, it just helps us, create a bit more depth in our chart, that we have these different layers. Okay, next we'll talk about the spines and the pips. And so pips is what I call them, these lines that come out, if I go back to the previous one. So these white lines that we have here that come out outside of the axes area. And so first of all, I've dropped them off. So I've done this, with down here with ax.tickparams. So on both axes, I've just set the length to 0. And again, it just means that we don't see them on the graphic. As well as this, I've removed the top and the right spine, and I've changed the color of the bottom and the left spine to white. And so I have a for loop here that will do that. So first we create a list of our spines, our top, right, bottom, and left. And we'll say if the spine is top or right, then set visible to false. Otherwise, set the color to the same color as our text color, which is white. Okay, and moving on to fonts. Again, for my personal vids, I like to use Allegria Sans. It's not something that is pre-installed on Macs, and as far as I know, on Windows. You can, change that to a font you already have installed if you're following along. But again, it just cleans it up a bit instead of using the default Deja Vu that we get from Matplotlib. So yeah, again, here, this is the standard Deja Vu. And yeah, I think it looks a little bit cleaner, a little bit more professional by using, a different kind of non-standard font. And again, so I've used title font and body font up here, and wherever I'm using text, I've just dropped those in. So font family equals title font. Okay, and looking at this, I saw that the gray was maybe still a little bit too bright, and wasn't really where I wanted it to be. And again, this goes back to the idea that you don't just create a graphic once, or, it's not just you follow these steps and it's done, but there's always a refining process to it as well. So having looked back at earlier points that I was looking at, I saw that the alpha value was 0.6 for this gray color, which is maybe a bit too high. I tried lowering it to 0.4, and I think, again, it just shows to the reader, okay, these are other points, but we're not interested in those. we're mainly interested in Arsenal and following this line as well. Okay. So yeah, next step was to adjust the title. So for this, yeah, I just moved the title over a little bit, and this is where we use the highlight text package. So in highlight text, you'll get more information on how this works from the repo itself. But yeah, essentially we are creating a string. So whatever team's goal difference from, you know, the start date to the end date. Yeah, and then we're just dumping this in. So our color that we'll use for the highlighted text is our primary color. We set that, yeah, up here, primary color is red. And yeah, we set our font weights, we set our font styles and so on here as well. So again, just by encoding this red color only on the 2019-2020, we save ourselves from needing to create a legend and create more chart junk just to tell the reader that whatever the red point is 2019-2020. So we're effectively killing two birds with one stone by encoding that within the text itself. Okay, next we'll have a look at the logo. So adding the logo here is quite straightforward. And for this, we can create just a new axis. So fig.add axes we can use. The coordinates here are where on the figure you'd like it. So 0.2 from the left, 0.96 up would be the bottom left corner of it, I believe. And then how, you know, how wide you want it and how tall you want it as well, just to create that. So from that, we can drop in a URL to an Arsenal logo and make sure that's PNG. I see quite often that people will use a JPEG file that's not transparent. And yeah, if you have a dark background and you have a non-transparent logo, it does not look good to have a block of white around the logos that you're using. So I saw this quite often with the football ref logos when they first started offering new data. Good to see now that they've, I believe, made a PNG available. So when you can, try to use a PNG or a transparent background logo. And yeah, so we load this in by using requests. Load the image then, and then use ax.imshow to add it to our visualization. Yeah, yeah, finally, just to add some credits on the end. Again, as I said earlier, when I add credits, I like to do it in italic. So as we see down the end here, by using fig.text, we can add the credits that we want. Font style is italic, size is a little bit smaller, and the color is our white text color as well. So I saw someone ask how you figure out these coordinates. A lot of it is trial and error. So, I mean, the fig itself, so this fig will be a bit stretched now because I've added a logo and I've added a title above where it was originally created. But when you first create a plot, or when you first create a figure, it goes from 0 to 1 and 0 to 1. And so generally that's how you can work it out. So 0.2, for example, will be, you know, somewhere around here. 0.5 will be somewhere in the middle. And that's how you figure it out. Yeah, by basing it off of 0 to 1. And again, even with adding titles, you know, sometimes you'll see I've added here a \n to create a bit more space between our main title here and the plotting area. So again, maybe 1 is here, and we've added a little bit of extra to the top here as well. But yeah, generally on a newly created figure, it goes from 0 to 1 left to right and 0 to 1 bottom to top. Okay, and so the final bit that I wanted to do on this was to look at this label. So the label on this, you know, it's kind of clear. It could be a little bit clearer. And this is something where we can use path effects to make this stand out a bit more. So in the previous bits of this, I didn't just use ax.text. I created it as a variable. For example purposes here, variable t. By doing this, we then get access to this text object. So that means that we can use t.setPathEffects and the bits that we have at the end here to add like a border around our label here. So again, it just helps it stand out a bit more from the scatter points that we have behind it. And, you know, it really helps the reader focus and be able to more clearly read what it is that they're looking at. On this as well, so line width, which we've seen earlier, I set this to 3. And the foreground, which would be the border color that you see, I just set that to the background. You could set it to white if you wanted it to be a bit more extreme, but I think by using the border color, you get a good division between the overlapping scatter points and the text itself, which just makes it a bit more readable. So yeah, just to kind of go over it again, we've essentially gone from this as our basic starting point, and, you know, using no parameters, using, you know, nothing beyond what we get with a standard Matplotlib visualization to this. And again, I think, you know, it definitely could use some improvements, but I believe it is a step up from what we have in the first place. And it is something that's a bit more professional. I believe it tells a very interesting story. You know, you could use this as a supplement to talk about Arsenal's development over the past few years. And yeah, and again, when you do use data from other places, it is always important that you provide a credit as to where you got the data from and the source. If other analysts are also looking to work with this data, if it's publicly available, that you help out the community in that way too. So just to wrap up, an alternative here would be just to use the RC params themselves. So how I've gone through what we have here, you know, it's not exactly as I would do it. Instead of having to create all of these as variables, I prefer just to create everything in a function for a theme. And from that, then just set the RC params through a theme. Again, because this is more of a newer to Matplotlib lecture, I didn't really want to get into that too much. But if it is something that you're interested in looking at, I have begun development on a package called ThemePy. You can find it on pip, or you can find it on GitHub. You know, I'm currently encouraging people to, you know, pitch in if they have any ideas that they would like to add to the application. Essentially, it creates files of themes that can just be read in with, you know, using theme.useTheme, which will then set all of these MPL params for us. Again, just to make it quicker, to make some nicer professional looking plots. And final point, if you are doing any work with your RC params, you know, if you ever just want to go back to, you know, the default and kind of start again, you can just create a simple function here. So if you kind of just want to go back to what it was, create this function, and then you just need to use reset matplotlib, and that will just go back to the defaults that you have when you first load the package. So I think that's all from me today. I think I went a little bit over time, so thank you for your patience. And yeah, if any other questions came up, I'd be happy to answer them while I can.
No, that's fantastic. Please write in your questions if you've got any more for Peter just now. Something which came up a few times in there, and I should say one of the reasons I asked you to do this with Matplotlib and to do it in Python was that is what we're using on the course for all the other data science things and the machine learning things. So it was very nice for that. But there was quite a lot of questions about, for example, using Plotly, using Tableau, how you integrate something like that, how you use Power BI, those sorts of solutions. And
I mean, so personally, so for me, I'm a bit of a control freak when it comes to this. So I'm not a big fan of, you know, the predefined libraries. I much prefer to work with Matplotlib because you can almost create anything that you can think of. You're not limited to what has been made available to you. It's highly customizable. For many people, that's maybe a drawback. So these are usually people who use ggplot in R. But yeah, I mean, I think for Matplotlib, the one reason why I'm such a big fan of it is the ability to create anything the way that you want to create it. I think if you're looking at Power BI or if you're looking at Tableau, while there is a high level of customization in Tableau, you still couldn't do it the exact way that you would want to do something. And for Plotly, it's the same thing. So, I mean, I like Plotly for its interactivity. I like Bokeh for its interactivity, but you just lose that element of creating something the exact way that you want to create it. And you're limited by how the developer wanted a certain, theme or a certain type of visualization to look.
Good. I was just trying to switch off your screen share there, but okay. Well, I think we're I think where everyone seems happy. Lots of thanks coming in on the but otherwise, yeah, lots of smileys. But otherwise, everyone seems really happy for today. So
cheers. I'll just say before, if I've missed any questions that you want to ask again, I'll just I'll send out a tweet and you can reply to me on the tweet and I'll answer them there.
Yeah, no, that's great. Thanks really much for your time. I'm going to start the live stream now. And for those who are, maybe I'll just say, can I just say for those who are on the course, next scheduled time is Tuesday, 10:15 European time. I will be going into the Slack this evening and trying to answer any questions that you have for those who are following the course unofficially online. So get in your questions there and I'll go in the Slack and try and answer as many as possible. But thanks a lot again to Peter. Everyone else is applauding online, I think. But
thanks. Cheers for having me. Hopefully I'll be on again.
Yeah.
Cheers.